So one of the main reasons I introduced us to this menagerie of function was to get a really good idea of what they look like and in order to help us better define a piecewise function. So a function is called a piecewise function if it's defined by different equations over different intervals of its domain. So for example, between -3 and 1, the red equation 3x plus 1 is defined. So this line is only defined over this interval. I also have that y equals 4 between x is 1 and y is 3, but 3 is not included because we've got an open dot. Here I have a closed dot so that over the interval from 4 to what appears to be infinity, we have the equation for a quadratic. So let's go ahead and practice graphing some of these equations. So the first piecewise equation we're going to graph involves two linear equations, right? So I have 1/2 x plus 2 as long as x is greater than or equal to -2, and I have negative x minus 3 if x is less than -2. So here's where x is -2. I'm going to go ahead and graph first. I'm going to graph 1/2 x plus 2 when x is greater than or equal to -2. So my y-intercept is 2. My slope's positive 1/2, so it's going to look like it's going uphill. So here's our beautiful graph. But once I get to -2, I draw a closed circle to show that endpoint is included. But my graph, 1/2 x plus 2, isn't defined if x is less than -2. That's where -1/2 x minus 3 is defined. So this one's going to be a little more complicated to graph. So I've got -3 is my y-intercept, right? But my graph isn't defined over here. It doesn't start being defined until right here, right? When x is greater than or equal to -2. So here's my graph of this function. So its domain is all real numbers, but it appears that its range goes from when y is -1, but not included, all the way to positive infinity. Now I have a linear equation and a quadratic equation. I have that f of x is -2x if x is less than or equal to -1, and x squared if x is greater than -1. So here's where x is -1. I'm going to go ahead and put -2x, so as long as x is less than or equal to -1, so that's going to be this side right here. And on the right I have x is greater than 1. So my y-intercept is 0, but my slope is -2, so I'm going to go down 2 over 1, typically, but I've got to graph it to the left, so I'm going to go up 2 over 1. Here's my first part where my graph is defined, 2 over 1. So here I have my line with negative slope, -2x. Next I have the graph x squared if x is greater than -1. So when -1 squared is going to be 1, so we're going to put an open circle there. And then we can graph our parabola accordingly. So my domain in this case is all possible x values. And my range goes from 0 all the way to positive infinity. Okay, so in our what I believe is our second to last example, we have that the absolute value of x is our function if x is greater than -2. So here's where x is -2, or here's where x is greater than -2, and x squared minus 2 if x is less than or equal to -2. So let's go ahead and graph our absolute value function if x is greater than or equal to -2. So -2 is not included in our graph, but the absolute value of -2 would be 2. Remember the graph of this looks like a V. So here we have the graph of our, Okay, there we have the graph of our absolute value function. Next, I have x squared minus 2 if x is less than or equal to negative 2. So let's plug in a couple values for x in order to determine what f of x is going to be. So if x is negative 2, which is included, right, that would give me negative 2 squared minus 2, which is 4 minus 2, so 2. If x is negative 3, that gives me negative 3 squared minus 2, which is 9 minus 2, which is 7. Okay, so I have a couple points I can plot. Let's plot them in green. So I have when x is negative 2, y is 2. Oh, that's included, right? We're going to put that right there. And then I have when x is negative 3, y is 7. 2, 4, 5, 6, 7. So here's the graph of my parabola. Because this dot filled in our open circle left because negative 2 wasn't included in the graph of absolute value, my domain now goes from negative infinity to positive infinity, and my range goes from 0 to positive infinity. So in all these examples, we had broken our domain up into two sections. This last example is going to have us dividing it up into three sections. So I have if x is less than 0, it's defined by x squared. So here's where x is less than 0. It's going to be this section right here. I have if x is between 0 and 3. I'm defined by the equation 2. That's just going to be a horizontal line. And then if x is greater than 3, I'm defined by 4 minus x, which I'm going to rewrite as negative x plus 4. Makes it a little bit easier to graph. So on the left here, I have my parabola. Let's graph that in blue. When x is 0, y is 0. We're going to have that here. When x is negative 1, y is 1. 4, and so on. So there's my parabola. Next I have, in orange, between 0 and 3, I have y equals 2. So 0 and 3 are included in this graph of y equals 2. Here we have y equals x squared in blue. Last but not least, I'm going to graph negative x plus 4. Remember, that's going to have negative slope, so it's going to look like it's going downhill. We're going to graph that in blue. My y-intercept would have been 4, so it would have been up here, but it's not defined. So here's the first part where my graph will be. Look at that beautiful piecewise function. Its domain is all real numbers, and so is its range. If you look at our horizontal values, we hit every single one. So its range is also from negative infinity to positive infinity.